Okay, so welcome to this video where we need to solve this integral. So this is the filling in the last bit of the steps in the class. So you can rewatch the lecture video on how we get to this integral. But now in this video, let's just focus on my tips on how to solve this integral. Now, this is basically on the one perspective, this is just a very tedious integration by parts. On the other hand, I'll just show you the steps, but on the other hand, I'll show you how I do it to make it a little bit more easier to do, not necessarily make it any really by any stretch of the imagination easy, but it sort of streamlines the steps a little bit. Okay, all right, so just recap what this is this involves an integral from 0 to L. We've explained why that is the case in the previous lecture videos. And this is integrating through a sign. M is any integer, so any number, it's just going to be constant as far as we're concerned. Pi and L is clearly a constant. Well, pi is clearly a constant, L is a constant. Okay, so sign some constant x. This comes up in a lot of just Fourier transform type integral comes up a lot as well. Okay, it turns out to come up here in projecting out the coefficients in PDE. All right, and we need to integrate through dx. Okay, so what is f? F is a function. It's a piecewise function, and it's decently imaginable. So it's from 0 to L, and it's split into 3 pieces. The first piece is an x, which goes, so fx and x, right? So x goes from 0 to L. The first piece is just over here. And of course, it ends at L over 4, because if this is x, right? Yeah, so this value would be the same as this value at x equals to L equals 4. Oh, that's a typo over here, L over 4. And then it stays constant over there, and you can match it up and check yourself. This just drops back down with a gradient of -1 down here, and it fits right back. Okay, so alternatively, we're just gonna see how to solve this integration by parts 3 times with all the steps. Okay, so the first step I'll do, right, go back to left-hand side, because it's a piecewise function, we need to split into pieces. Now, this is a step I'll use blue, is the traditional step, and then I'll show you in black where the steps I actually take is a semi-shortcut, just to save a little bit of writing, not extremely short, but just save a little bit of writing and speed up your flow a little bit. Okay, so the traditional step is you go from 0 to L over 4, where f takes the value of x. So you write this part plus L over 4 to 3L over 4, where f takes the value of this. I'll put it in brackets just to be clear, m pi x over L. And the last bit from 3L over 4 to L, where x takes the value, sorry, f takes the value of L minus x. Like this. Okay, so this is traditional steps. What I sometimes do is I just write this x plus L over 4, 3L over 4, L over 4, plus 3L over 4 to L and L minus x. Like this, sine m pi x over L dx. So in some sense, I kind of factored out the common, quote unquote, common factor of sine m pi x over L to the right, and directly just write this. Is it the most rigorous? Yes and no. In principle, yes, if you know what I mean. Is it common? I don't see a lot of textbooks write that out, but it's rigorous as far as I'm concerned, and it's completely fine if you want to do it in your exam in this class as well. It's understandable, but you need to know what you're doing. Okay, and then the next step I would do is this. So you can go with the standard way of go and let, for example, here, right? So this would go to u equals to x, du equals dx. dv equals sine m pi x over L. Again, this is the usual way of m pi over L cosine m pi x over L, differentiating, I put a minus sign. So this is kind of the usual way you would go, right? So just double check. Always going up here is a little bit more tricky. So I will take this and go down and check that if I get it right? So cosine goes to minus sign. So this minus take care of that. And then it has to spit out the coefficients in front of X, which will cancel out that. So that can be simplified, but I'm not going to do it this way. Yeah, so that's the usual way you go about each of them. A little bit of sidetrack, but I'll show you a arguably more brain power demanding way, but presentation-wise, make it a little bit cleaner. Okay, so and at the end, I'll erase the blue bits and you'll see what are the steps that remains. Okay, so I'll have this whole thing over here. Now I'll do the integration by parts at the same time for all three of these. Okay, I'll show you what I mean. So this part, I'm going to absorb the sign into the D. Okay, so it's going to go into the D. So if it goes in, I probably need a cosine, right? Because now if you do the implicit differentiation backwards, right, differentiating cosine will give me sine of this dx. But now I need to take care of the factors of the coefficients and the minus signs, right? So I need to divide because if I go up, yes, I'll get this piece, but I'll also get extra factors of m pi over L. So I need to divide by m pi over L, right? So when this comes out, it'll cancel this and also the minus sign because the cosine will turn to minus sign. So I'll need to divide this piece on the bottom. So do the implicit differentiation over here. This should reproduce exactly this part, right? And I can just copy whatever I have here. While I need to copy this part, might as well do a little bit of simplification. Nothing much I can do with this, but for this piece, I can pull that out. Okay, so just for presentation wise, we'll do this. That, okay, all right. And then now the next step, what I can now do is the integration by parts trick I showed you, right? So first of all, this factor is an overall factor that applies to everything. It's in some sense the Jacobian. You can pull it all the way out in front, and let's swap the fraction as well and deal with everything else remaining here. Okay, so the first piece is this times this. Now, remember when we have, so what we are going to do is change that into d of x times cosine m pi x over L, like this. Okay, so I'm just going to put the x in, but of course that's over differentiated or over integrated. I don't know which way I should think about it, but this is a little bit too much, right? So I need to subtract away a piece, and let me subtract it below. Okay, so I need to subtract away the piece where I keep this constant and just differentiate this. Okay, so right, so these two terms combined, right? These two terms combined should now represent this. Okay, hope that makes sense. Let's think about it one more time, right? First of all, I take care of the overall factor. It's pulled out over here with a huge brackets that's going to enclose everything at the end, right? So we're not going to worry about that. So now I need to take care of this piece, which has an x and x times d cosine something. So it's the same as differentiate the whole thing, but this I need to break into a product rule, right? So the first piece is keeping the x outside and differentiating just this, which is this, x outside and differentiating just this, okay? And the second piece over here is keeping this outside, right? Keeping this outside and differentiating just x, okay? So these two together should reproduce this piece, okay? Now let's do the second term. This is even easier, right? I could just write the integration, but the integral of it, but let me, yeah, split it into two steps just for clarity, right? So just like this. Okay. And there's no integration by parts anymore for this guy because there's nothing here, okay? And the last one, I'll do the same thing. You'll get the hang of it once you see it once or twice, right? So now I will forcefully squeeze this in by force, right? But of course, that's too much. I need to subtract away because once I squeeze it in, it's not going to equal this. So I need to subtract away because this will produce two pieces from the product rule. So I need to subtract away the piece where it's just integrating where I need to pull this out, m pi x over L and d of L minus x. Well, this is an implicit integral, and this is actually just minus dx because L is a constant. We'll separate that in the next step and just close our bracket for now. Okay, all right. So the next step is I will do these integrals, which is really easy to do because integrate d whatever is just this, right? And then you just need to put in the corresponding limits, right? So if you look at this, this is easy to do, right? This is immediately, right? It's done. It's just this putting in the limits. It's just this putting in the limits. It's just this and putting in the limits. That's fine. Okay, here, this is an easy integral to do. And here I need to take care of this piece, but once I do, like I said, that's minus dx, and once I do that, that's fine. Okay, so let's see how that works. So we have minus L m pi, again in front, and here we have x cosine m pi x over L, 0 to L over 4, plus L over 4, and cosine m pi x over L, from L over 4 to 3L over 4, plus L minus x cosine m pi x over L, from 3L over 4 to L, right? Minus. Okay, so integrating this now, it's going to be sine m pi x over L, and need to throw out L over m pi in front. And I always just double check if differentiating this gives me back this. So differentiating sine gives me cosine. It's going to spit out this part, which is going to cancel this part. And the minus sign is correct. Okay, good. And the last bit over here, I'm going to remember, I'm going to do this in my head, right? So this is minus dx. So you know what? I'm just going to keep that for now. But yeah, so this is going to turn into a plus. And it's going to, oops, I need to put in the limits over here first before I forget. And it will have a L over m pi again, sine m pi x over L, okay, from 3L over 4 to L. Okay, so I'll always double check. This is how I do it. I sort of do it in reverse. So let me check if I differentiate this, what give me this. So differentiating cosine, sorry, sine gives me cosine, and this will come out and cancel this. And the sine would otherwise be correct if I take into account of this minus over here. Okay, all right. So now I can just close my brackets and go ahead and simplify this chunk. Okay, so we'll plug in each of these limits over here. Okay, so we have L over m pi. We'll keep this out here. Okay, so this is relatively easy to plug in because the zero terms when it comes in here, it just annihilates this. So we can just plug in the L over 4 times cosine L over 4. So we have m pi L over 4, but L cancels out. So I just have m pi over 4. That. Okay, and plus L over 4. And here we have, we actually have both terms. So we free m pi over 4 minus cosine m pi over 4. The L cancels out. And plus, now the L, the first term when L comes in here, it annihilates it. So I just need to plug in this term over here. So L minus 3L over 4 is L over 4. And cosine 3m pi over 4. Okay, and subtract L over M pi. Again, even though I have two limits, only one will survive, the other one is 0. So it's just going to be sine M pi over 4 plus L over M pi again, and sine, when I plug in L down there, it's going to, yeah, we'll keep both terms first, but the next step will understand that the first term will go away in here. Oops, over 4. Okay, close our brackets. Okay, all right. So now let's see. We can check what's going to disappear, right? So this is going to disappear because, again, look at the unit circle. This is very, very helpful way, the sine, cosine. So M pi is any integer values of pi. So 0 pi, pi, 1 pi, 2 pi, 3 pi, 4 pi, right? It just goes on here where, oops, did I put this wrongly? Yes, I put this wrongly. Cosine and sine. Right. So sine always is 0 for that. So that goes away. And now we can double check over here, for example, this term over here is exactly the opposite of this term with the L over 4 in front. And this term over here is exactly the opposite of this term. If I get my minus signs correct, yes, there's an extra minus sign here because when I plug in the L, it goes to 0, and then I need to subtract, right? I need to subtract when I plug this in. So that's the subtraction. So it's 0 minus when I plug this in here. Okay, so these two will cancel. Okay, so yes, let's check again. That cancels that with together with that cancels that. So we're left with just this. Okay, so we can pull this out. We have well, we have L over M pi. Let's get this minus out there and pull out this piece as well. Right. So we'll make that. Yeah, we'll pull out this and this and leave. Yeah, so we have a square over there and leave the minus signs over here. So M pi over 4 plus, well, that's going to be a minus because of that, right? After pulling out that piece, we have, yes, minus sine 3m pi over 4. Okay. I can get rid of some of the brackets, but I'll keep it in here like that. Okay, and we just need to simplify this. So the minus signs will now all cancel. And we have sine m pi over 4 minus, that will become a plus sine 3m pi over 4. So here you might want to see if there's anything you can do with the m pi's over 4 and 3m pi over 4. But the m pi, right? So m pi over 4 is every quarter of a pi. So from here is 0, here is pi, right? So this is half a pi, this is a quarter of pi. So m pi over 4 is every quarter. So here, 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 etc. It takes different values every time, or different m, so it's nothing I can simplify. 3m pi over 4 is the first time it happens is here, and then 1, 2, 3. The second time is here, 1, 2, 3. The third time is here, 1, 2, 3. So again, sign of that will take different values. So there's nothing I can really simplify. Okay, so that is the end of this integral. If we want to, so this is the whole steps over here. If we want to combine it with the previous what we did in the class lecture video. So on the left hand, remember this is the left hand side. On the right hand side, we had L over, I believe it's L over 2 cm, right? Okay, so now when we equate the left-hand side to right-hand side, that will imply, what do I have in the left-hand side? L over m pi square, And yeah, it's unnecessary to use such a big bracket. We'll use a medium bracket. Sine of m pi over 4 minus sine of 3m pi over 4. It's left hand side. The right hand side is over 2 cm. Right. So cm. This is a good chance I'll change it into an n as well because it's just nicer later on. So this is 2 over L and then L over n pi squared sine m, change all the m to n. Just be careful, don't miss some of these. 3n pi over 4, like this. Okay, and put it back into the, so this is from class video, right? We have that. So now putting it back together, where we want to solve for this, which was, right, it was x of x and t of t, right? And that will be summation of n from 1 to infinity. We have the first part, which is sine of n pi x over L times cn of sine of n pi ct over L, like this. And this is where it goes in here, okay? We'll see what we can pull out. There are some things we can pull out. The 2 over L can be pulled out. That's nothing to do with n. This n has to stay inside, but everything else, so the L square and the pi square can go outside. And there's some simplification you can do, but yeah, that's not much otherwise. So we have this, so sine n pi over 4 minus sine 3n pi over 4. So this whole thing is the cn, and we have sine n pi x over L times sine of n pi ct over L. So I'll put the brackets over here just to signify that is the original cn. Okay, so this is the full solution over here. You could cancel that if you want, so it's 2L over pi squared. But yeah, okay. So hope so. This is putting sort of the everything together. But in terms of just integration by parts, so this is sort of one way. Again, if I erase out things that are that could be saved, it's not a whole lot. It's still a lot. So let me just scratch out some of the scratch work, some of the rough work over here. You will see it's a little bit cleaner, but I wouldn't claim it's terribly simple. But it's a different way of doing integration by parts. It's sort of, it's a little bit more linear. I don't need sort of, the benefit is I don't need side work. Everything flows. Your logic sort of goes straight forward. It is a little bit more demanding on the mind. Again, if you use whatever method you like, but this is just to give you a different perspective. If you want to train yourself a different skill, this is nice to do sometime. If you get the hang of it, this will be faster. But yeah, so there you go. Let me know if you have any questions. Be happy to answer them.